So in this lecture, we are going to see hash functions. Hash functions are extremely useful and appear in all information security applications. Hash function is a mathematical function that converts a numerical input to another compressed numerical value. The input to the hash function is of arbitrary length, but output is of same length. Values returned by hash are called message digest or hash values. So we have a message, a hash function h, and the hash value small h of fixed length. So fixed length output is known as hash value. Hash function converts data of arbitrary length to a fixed length. This is known as hashing. In general, hash is smaller than the input data. Hence, hash functions are sometimes known as the compression functions. Means the value h received is sometimes smaller. Since a hash is a smaller representation of a larger data, it is also referred to as digest. Hash function with n bit output. Okay, hash function with n bit output is referred to as n bit hash function, and popular hash functions generate between 160 and 512 bits. Let's see the efficiency of operation. Generally, for any hash function h with input x, computation of hx is fast. Hash functions are much faster than symmetric encryption. Properties of hash functions. Pre-image resistance. This property means that it should be computationally hard to reverse a hash function. In other words, if a hash function h produced a hash value z, then it should be difficult process to find out input value x that hashes to z. This property protects against an attacker. Second, pre-image resistance. This property means that given input and hash, it should be difficult to find a different input with the same hash. In other words, if a hash function h for an input x produces hash value hx, then it should be difficult to find any other input value y such that hy is equals to hx. Collision resistance. This property means it should be hard to find two different inputs of any length that results in the same hash. This property is also referred to as collision-free hash function. In other words, for a hash function h, it is hard to find any two different inputs x and y such that hx is equals to hy. Now, designing of hashing algorithms. At the heart of hashing is a mathematical function that operates on two fixed size blocks of data to create a hash code. The size of each data block varies depending on algorithm. Block size varies from 128 to 512 bytes. 512 bits. So these are data blocks, hash function, and hash value. Hashing algorithms involve round of above hash function like a block cipher. Each round takes an input of a fixed size, typically a combination of the most recent message block and output of the last round. This process is repeated for as many rounds required for hashing the entire message. So we have the message block 1, 2, n, and then we hash with the seed value, and finally we get the hash value. Since the hash value first message becomes input to second, output of which alters the result third. So this is known as the avalanche effect of hashing. Means the output of first is the input to the second hashing, and so on, and third, and so on. Then we have some popular hash function. One of them is MD, message digest. MD comprises of hash functions MD2, MD4, MD5, MD6. 128-bit hash function is there in MD. MD5 has been widely used in the software world to provide assurance about integrity of transferred file. Next is SHA. So in SHA we have the SHA 0123, SHA 0 is 160 bit, SHA 1 is used in SSL, SHA 2 has various variants. So SHA 2 is a very strong one. Then ripened algorithm is there, race integrity primitive, evaluation message digest, it's not on a course, Whirlpool is there. Now let's see application of hash functions. Application of hash function is password storage. Instead of storing password, the hash value of passwords in the file are stored. The password consists of a table of pairs which are in the form of user ID and h of p. The process of login is described in the process. And then the next is data integrity check. Helps the user to detect any changes made to the original file. It does not provide any assurance about originality. The attacker, instead of modifying file data, can change the entire file and compute altogether the new hash and send to the receiver. So originality of file is not ensured, but the hash value uh, is assured. So these are the applications of the hash function. Let's come next to the hash functions. इंटीग्रिटी चेक के लिए यूज होता है. Integrity means attacker cannot tamper with message. Confidentiality means he has not seen it. Here to use hash function for password storage and for cookies also. Purpose of the hash function is to produce a fingerprint. What is a fingerprint? This we already know, secure hash functions. These are the common hash functions. Authentication is identification and assurance of origin of information. HMAC construct MAC by applying cryptographic hash function to message and key. Okay, so this is all about your hash function.